warm welcome. I see some folks online, and we have a core crew who showed up in person. Welcome. So 2 returnees and a noob, right? Yes, welcome. So just for Craig then, and anyone online who's new, my name is Adam Hems. I, along with Kim Vardy, lead the Houston Azure user group here. Have done since 2016 or so. And this group is about learning from one another and from our presenters, not a sales pitch. So this is all things Azure. We try and meet once a month on the second Tuesday of every month. And tonight's food is sponsored by Avanade. So we thank Avanade for feeding us tonight. And I think that's probably it. That'll do it. With that, I'm going to hand over to Russell. Is your mic on, Russell? Okay.
Yeah.
All right. Without further ado.
All right. First off, thank you guys for having me. My name is Russell de Pina. I am a principal technical product manager on the AKS team. We work with primarily on the platform growth side. So we do a lot of work. We work with customers. We interface with engineering. Sometimes we bring customer problems to the engineering group. A few of us also manage certain features in AKS, so we kind of get involved with that. But yeah, that's what I've been doing. That's what I'm doing right now. I've been at Microsoft for a little over 3 years now. I started at Microsoft as a principal SWE and got reorged into a TPM job. But considering the layoffs we had earlier, I'll take the reorg and the job title switch over that. So and actually I get to have a lot of fun, because one of the cool things about being a TPM is that you may have some feature responsibility, but you don't become a DRI, which is the person who gets called at 3 o'clock in the morning when something breaks.
Directly responsible
individual. That's it. So but anyway, so let's get into it. So we're going to talk about container secure supply chain. But before we do that, we already did recognize our tonight's program is brought to you courtesy of our friends at Avanade, or at least the food is. So we wanted to give them a shout out, thank them for their continuing support. Okay. So our agenda, we're going to do a little quick introduction and then talk about securing the software supply chain. And then we'll do an introduction to the Microsoft Container Secure Supply Chain Framework. And then we'll do a little demo, hopefully. So securing the software supply chain. It's like, how many of y'all remember SolarWinds, the SolarWinds attack? And then, we had, there's the PyPy, there's CodeCov, all kinds of attacks that have been in the news. 2 that are really significant for us from a software perspective is the XZ-utils and SolarWinds. And what makes these 2 attacks so special for us is that they were not direct attacks. In other words, the attackers, those exploits don't come through a vulnerability in an application, right? They came like SolarWinds. The SolarWinds attack vector came through a component that was used to build SolarWinds application. And similarly with XZ-utils, right? XZ-utils is a popular library that you find in Linux repo, in Linux distros, and just happened to have a vulnerability in there that allows an attacker to come in through the back door. So what we're talking about is, some of these, we can't stop hackers, right? So, why do bad actors think that these kinds of things will succeed, right? With these kinds of exploits, why do they think that they could succeed? Well, mostly because developers don't pay attention, right, to security until after an incident occurs, right? Today, and you can raise your hand, this is probably you. You've built something, you've gone to a public repository or Docker Hub, you've just pulled an image down and says, oh yeah, this works, it's great. It builds, right? Works on my machine, it builds. You build a container, you build your app, you build the container, and everything is copacetic. You go and you run your unit tests that test for functions, but you haven't done any vulnerability scans. You haven't looked for anything in any of the images that you brought down, right? Or maybe you're actually coming from a secure. We've got technical difficulties here. The screen's not changing. Let's try this. Nope. Anyway, so maybe you are pulling from an approved repository, but the Helm chart is calling out a specific version of the image. So it doesn't matter what the repository is. Now you're pulling a version that may not have been patched, may have a vulnerability in it. You have literally no, so what you wind up with is literally no control over this software supply chain. So how do we address that? And the way that we look at addressing that is with the, wait a minute, the screens are not, I think I stopped, somehow my presenting turned off because what's on this screen. Let's try this again. Present in Teams. Hold on a second. Let's see if we can get that present. Let me know if y'all can see. I think that's why somebody's hand's raised. Zoom. Yeah. So we've got this. Yeah, here we go. Most developers don't. Yeah, here we go. So like I was saying, you can, if you're pulling from an approved repository, but you've tagged an image in the Helm chart, so you don't have any control. So how do we address that? So one of the things that what we'll do is we're going to introduce the Container Secure Supply Chain Framework. There's lots of docs on this. Basically, it is the supply chain. You've got the acquire, right, which is pretty simple, right? Acquiring container images from external sources or third-party vendors. So this could be, GitHub Container Repository, Microsoft Container Repository, Docker Hub, or an approved approved vendor. But then you've got the catalog stage of the supply chain, which offers approved container images for your consumption. So rather than just grabbing container images from any place and where you can't verify them, the first thing you do is when you acquire them, you acquire signed images. Or you acquire images that you can from trusted sources. Once you've got those, then you put it in the catalog, which gets us to the next stage in the pipeline, which is the build stage, right? And this is where we produce compliant images that we're going to use downstream. Right, so this is where we are going to generate and produce our compliant application images and service images that we're going to use in the deployment stage, which comes next. Right, and so now what we're going to do is we're going to securely deploy containerized services and applications to the hosting environments. And then finally, we're actually running. Right, so now we're going to run containers that are created from compliant latest versions, secure container images that are executing either the business logic or an application or some kind of service. And over all of this, it doesn't help unless we can see what's going on. So observability is a big piece of how this all works. And so let's look at how this kind of plays out. So when first we acquire the bits that we need to speed up, we're going to speed up our development process, right? So we're going to grab some container images. These could be open source images or libraries, vendor SDKs, could be anything. But before we actually acquire them, we need to verify that they come from trusted sources, right? So one of the things that we can use is using signing technologies like the Notary Project, which is open source, allows us to verify the authenticity and integrity of software artifacts, right? Other things that we can do in this acquire stage is actually to go and build compliant open source projects. Microsoft contributes to, there's a project called Dalek that is on, you can find it in GitHub, and Dalek is used for that purposes to build compliant container images. And then finally, basically to grab our images from trusted sources, approved repositories, not just any old repo out on Docker Hub or God knows where. Right, so that's our acquire phase. And then when we get to the build phase, right, identities can be compromised, which is why we should use an approved catalog and just not allow random image pulls from the internet. The catalog part of the supply chain addresses this, right? We can use things like pull from image sources that are compliant with the Open Container Initiative, which basically sets some best practices for making container images available on the internet. Also using tools you can do automated scans for vulnerabilities and generate software bills of material with tools like COPA, so that when you are grabbing images, that those images not only come with the code that you're going to run, but also come with some metadata that tells you exactly what's in there and how it's been checked and basically certified, right? Now we get to the build part, right? And we're not just about building binaries, right? When we're going and we're building containers or applications, when we're building containers for downstream users to use, or services for downstream users to use, or even just our own containers, the thing is that we need to sign them. We should be able to generate a software bill of materials so that anybody that uses that knows exactly what is in that. Knows exactly what components make up the artifacts that we're sending downstream. Anybody who is building applications for the government, they have to do this, right? You have to generate an SBOM, a software bill of materials, for government apps. But the thing is that this really just makes sense for everything that we build. You want to be able to have attestations about the software that we're building, right? So we've got other tools in here like the System Packet Data Exchange Standard. We can use that when we create artifacts that are going to describe our software and container images. And then we also have our old friend Dependabot, right? Dependabot can actually be used as can now update image references in Docker files and Helm charts and K8 and Kubernetes, right? And so we work with, you can all add these things to your workflows as you roll out software components and applications. And then also to kind of finalize this step, you can also use Qualsys and COPA, because sometimes during the build phase, right, with COPA, you might want to apply patches. You can check you can check the dependencies on that software, and maybe you need to update the images during the build phase as well. So open source tools like COPA and OCI will help you do that. So. And then finally, we get to the deployment stage, right? Now our application is ready to deploy. So how do we make sure we follow good deployment practices, right? We can use admission controllers like Gatekeeper and Ratify that ensures that the workloads are compliant from the start. And then also when we get to the, now that we finally got our application running, again, we can use Qualsys. We can maybe check for misconfigurations and and do security scans, things like that, to make sure that even while we're running, that we are compliant, that our applications and containers are secure. Okay. And then finally, we talk about observability. We talk about observability a lot when, with regards to our applications, right? Being able to see what's going on while our apps are going, pushing logs and things like that, so that, God forbid, something goes wrong and you get that call at 3 o'clock in the morning, you can see what's going on. But all of this software supply chain does not work if you can't see what's going on. Right, so you have to, in these workflows, you really need to have some end-to-end visibility over what's going on in the supply chain to keep that secure. And to that end, like Microsoft, what we do is we collaborate with the Guac project to basically enable developers to see what is going on and be able to build dependency graphs so that you can basically view and observe, understand how your applications are composed, and along with the software bills and materials that you generate in in some of the prior stages in this build chain. You could take all of that data, and in the case of containers, we can use data from AKS and the Azure Resource Graph to quickly identify places where we might need to patch and remediate things. And then also, finally, again, as part of your secure supply chain is to implement zero trust. Right, we talk about zero trust in networks and things all the time. So what is one way to implement zero trust in a secure container supply chain is to only allow images, is to only trust software artifacts that come from either the previous stage or approved and trusted sources. Okay. And so now's the time for, now we'll do a little quick demo. I don't want to stop sharing. I think we might run into some technical difficulties here. So because I'm sharing out of PowerPoint. Let me know if you can see my screen. Yeah, you can't see my screen. So here's what I'm going to do. Go to PowerPoint. Did I stop sharing?
Not yet. No,
Not
you
yet?
still got your PowerPoint up.
Oh, okay. So
if you just do share your screen.
yeah, so
And share from there, that one.
yeah, so if we share the screen. Okay, so this is at least
No, you could hide that. You want to put your desktop up?
Yeah, just, yeah, here. Let's see, what do we got here? Wait a minute, so what we've got, wait a minute. No,
There you go. It's popping up.
yeah, but that's the wrong one. That's the wrong browser. We want Edge. Yeah, this is the one. This is the
There we
right.
go.
Yeah, that's the right one. Okay, so what we've got is a little demo. And here, let's.
I'm sorry for the watermark. I don't know what happened.
Nah,
It's
yeah.
it's just all over.
Ooh, somebody's got a mic on. Okay, so is that me?
Might
You think
be.
we can stop recording and, when we fix
Yeah.
this, is to stop it, rejoin?
Speakers. That one. Click on that icon.
Yeah.
That's it.
Okay, cool.
The sharing's working now.
Yeah,
Yeah, the only thing is the watermark is really annoying. The
Yep.
only thing we can do is stop it and restart it again.
Oh, it's okay.
Sure?
Oh, yeah. I'm stuck with it. I can see it. Yeah.
as long as you guys can see what's going on, right?
Yeah.
Okay, so this is just a really kind of quick demo on how to incorporate GitHub Action into or how to incorporate signing your container images into your pipeline, right? And so what we start with is we've got an Azure subscription. And in this Azure subscription, what I've done is I'm not gonna share all of the real detailed bits, but what we've got here is I've got an Azure container registry that I've set up, and I have a key vault. We've got key vault right here, and now the things what we're going to use the key vault for is inside the key vault. We've got a self-signed certificate. Now in production, you wouldn't use a self-signed certificate. You would have something that was issued from a CA authority, yeah, from a certificate authority, a real certificate to sign your images. But that's what we've got. Now the other thing that we have is a GitHub repo. And find it. Of course, the browser is being blocked by, there we go. Which one? So, yeah, here's my work. Show this one. Ding, ding, ding. It's mine. No, that's not the one. This is the one. So we've got this repo called Hue demo, and I set this up for tonight. And all it's got two files. We've got a little Python file, it's a little application, and all this application does is it accesses an Azure storage account, reads from a queue. It's called a queue consumer. Nothing special, it's just so that we can demonstrate this. So, and then the other thing that we've got is a Docker file, so that we can build a container. So all we're doing is containerizing the queue application, right? Real simple. But in order to automate this, what we've got is we create in our repo, we create a .github directory workflows so that we can implement our GitHub actions. And in our workflows, we've got this one workflow called sign image. And inside the sign image, this is a YAML file where we have our container registry, the name of our repo. We've got a key here, the key for signing the registry. Now, how do you get this key? Well, we've got a certificate, right? And so if I go back here, we can see if I wish I could make this bigger. And get rid of that. So we've got this command here, right, where we can show the key ID on the certificate that we have in our key vault. And there is our key name that we're, I share again. Let's go back. Share screen. I guess, yeah, this one. Yeah, okay. Let me know when you can see it again. Yeah, because what happens, it pops the banner up, says, "Oh, stop sharing it." So I clicked on the button and I clicked on the window banner and it stopped sharing. So yeah. So anyway, here's how you get the key that you're going to need in here. And so that's this key ID. And what we're doing here is we are setting up a GitHub, we're setting up a pipeline GitHub action. We're going to log in. This does the login using your, what you do is the other thing aside from the key vault and the container registry, yeah, we created a service principal, right? Because actually, this lab is actually sitting in the quick starts in our, you can find this in the Azure docs. Now, there's some things that that I do here that that we don't do that they don't do because the Azure quick docs are, the Azure docs are a little bit, they need to get updated. Let's put it that way, right?
You need to create service account.
Yeah, you create a service principal. So yeah, so when you do this, you have to have, enough mojo to assign roles and things like that, because that's where what I've done in this demo departs from the docs, right? Because the docs, they use just old-fashioned Azure access policies and secrets, which is not best practices anymore. So what we do is I've RBAC enabled the key vault and the container registry, but mostly the key vault, which means that even though I'm still using a service principal, I now have to assign the roles to it.
Do you use a key vault extension?
For notation, we do. We actually, we use the Azure Key Vault extension, and that's actually what I was getting ready to show y'all. Once we log in, we set up notation, and then we sign it. And right here, we're using the Azure Key Vault plugin from the Notary Project to actually sign the registry.
So, question is by doing this, whenever there is an update in Key Vault,
exactly, that's exactly what happens. This is going whenever we do a push to main, right? Whenever we do whenever we execute a pull request, what's going to happen is this GitHub action is going to do a build on the Docker file, and then it's going to sign the image using notation and push it to our container repository.
Yeah. So certificate gets installed in the registry.
The
Container.
The container is signed with a hash that comes from the certificate. Exactly. That's it.
So this, I guess, it's very similar to the DevOps. If you want to deploy something from DevOps into your subscription, you need a service.
You need some kind,
Then it updates the certificate all the time. I guess it's very similar.
Yeah, very similar to that. Yes. Yeah, because there is a demo they're all in the quick starts. If you look in the Azure docs for the container secure supply chain, you'll find this demo. What it does is it uses access policies. One of the things a couple of the things that I did that were different. One, we use RBAC, right? Because that's what suggested best practices. The other thing that we do in the demos you're building you set up your container registry and key vault. They're naked. They're facing the internet. Any public network can get at them. What I did was to assign network rules, access rules.
Okay.
So on, it's a cloud, it's one of those kind of cloud resources it's just in Azure, but you can only touch it if you're coming from a network that's allowed.
Yeah.
So that's, so these are things that that you want to take into account when you do something like this. So I believe.
If one of those resources doesn't provide identity management for login into database, probably you could use this, I guess.
Yeah.
Are you using?
Oh, wait, what was that again?
There is if some resources doesn't have identity management. Identity.
Identity management.
I mean,
Managed identity?
yeah, managed identity. If you don't have those managed identity, I guess probably this is another way where you can actually use to log in into your database.
Well, yeah, you could, yeah, if you.
Because you are actually getting access to your service principal, and then you can do RBAC and all that.
Yeah, because typically with GitHub pipeline actions, you're usually you're saving credentials.
Right.
As secrets in the GitHub repo.
Yeah.
That because
you can use SQL. You can use external.
Right.
For that managed.
Yeah. Now, yeah. So because that could be. It's like if you're building an application, you're building a container that's going to log into a database.
Yeah.
I
don't know if there is a managed identity.
Well, if for on the build stage, say if you're building a database container or you're building an application that you're going to deploy in a container that's going to log in a database, right? So somewhere that application is going to have to get either you stand up in order to test it, right? The application needs to be able to get a credential from someplace, right? If it's a container, then the application should ideally get the secret from the Kubernetes host.
Okay.
At that point, you can, you stand up on your Kubernetes cluster, you could deploy something like an external secrets operator, or you can explore, you can use ESO if you're totally open source. If you're okay with first-party Azure solution, you can use the Azure CSI driver, and now all of a sudden your secret store becomes just another storage class that you're using.
Yeah.
Right. So so you can do that kind of thing, and then your app can grab the secret from there.
Yeah.
And and then when you stand up you basically make those secrets available to the pod that the application is running.
From Vault, you mean to say?
Pardon me?
It's coming from Vault, eVault?
You can use it, yeah.
Oh, okay.
Yeah, if you're like, if in
That's
Kubernetes,
the problem.
yeah, in Kubernetes, they have there's a driver so that you can use the external secrets operator with Azure Key Vault. You can use it with HashiVault. You can use it with AWS's Secret Manager. And whatever the GCP equivalent is. That there's a ton of there's a ton of drivers for those kinds of things. And then as like I said, at Microsoft, we also have a first party operator that you can use called the Key Vault CSI driver. Then basically that, kind of what the name implies, it basically makes the Key Vault look like a storage class.
Oh, it's
yeah, so you just mount it as a volume and grab secrets. Yeah, so this is what the template file looks like to set up the workflow, right? So we log into Azure. It logs into Azure, basically sets up notation, and uses the certificate that's in the Key Vault to sign, to basically go and sign the container image that we're building, right? And then there's yeah, here's the build and push phase, right? It's just going to build a container image. So if I've got a code space sitting around here.
So
somewhere.
anywhere in this code, you don't provide any password for your
No.
managed.
No secrets are there in
Because it's through the certificate.
right. You're using the certificate to sign the image. The only place where there's any secrets stored are in the GitHub repo itself.
Yeah.
And and in the workflow, those actually here, if we can go back, I can show you. When we look here at the when it logs into to Azure,
Yeah.
you've got so you see here this is telling me that I've got a secret in my repo.
Yeah, that's actually just the client ID,
Yeah.
which is useless unless you have a certificate with you.
That's right. Yeah. Yeah. So and then the only difference here is like that I did to update the demo here. If you're using a self-signed certificate, you have to tell notation that you're doing it. But when you want to build this for prod, basically you'd comment this piece out and uncomment that. So you could use that way you're using, you're going to be using a regular cert, and then you just have to tell where your cert bundle's coming from.
So what access policy you will set up in Key Vault in order for this to actually go into Key Vault?
I didn't set up any access policies. I used, because my Key Vault is RBAC.
Oh, RBAC, okay.
Yeah, so what I had to do is on the service principal here, that on this service principal that we logged in with, this ID.
Yeah.
So on that service principal ID, I had to make sure that he has enough mojo to grab a certificate out of the Key Vault, because otherwise that signing step is going to fail.
Oh, I see.
Yeah, because the identity, because this step is actually, if it was this step is using that service principal as a managed identity.
Yeah, yeah.
So that identity, managed identity is just a service principal with another name.
Yeah. Right.
So basically what's going on is we have to assign RBAC privileges to that, as opposed to if, with access policies, it's, with access policies, it's just, oh, give me the key, right? And I can get in. But if you're using RBAC, you don't need the key, because the access is given to you, is scoped by the privileges that are assigned to your identity.
Oh, I see. Okay, gotcha.
Yeah.
Okay, gotcha. Yeah. So in that case, if this client ID or that tenant, if it's leaked somewhere, can they actually still use that?
I mean, it's like any secret, right? But in this, you've got to divulge 4 pieces of information.
Yeah.
Right. And if you can get 4 pieces of information in a while, I would submit you've got bigger problems.
Yeah.
You've got some bigger problems than just this. Okay, so but yeah, so once this is all set up, and then basically where are we going? Yeah, if we go to our actions, we can see that we did a this will only rerun fail jobs. So, but if we can take a here, let me go and let me see if I can find the let's go to the, I'm trying not to stop sharing, but I got to move this window so I can see stuff. So we'll go to code, and then we I do have a code spaces around here. So let's see what happens here, right? And this is taking, almost there. It's almost there. Yeah, there we go. Cool. So let's go to our, let's say we're going to add something here, right? All right, so we're just going to add a comment, whoop-de-doo. And now we'll go here, stage our change. Commit that, give a little push, and then we'll go back to, where's our, now I gotta find it. It's not the one. That's not the one. All right, oh, wait a minute, yeah, so we'll, here, just make a new tab. Put 2 S's, not 3, right? Yeah. And we can't reach it. Oh, GTI, yeah, there we go. Dyslexia does it again. All right, so if we go to our actions, we've got this one that we were just putting in, and this guy's cooking. And if we go take a look and see what's going on, right? It's doing the build and push. So now it's basically what has happened is we made a change to a source code file, pushed it, since we're doing we're working out of the main branch just because this is a demo. So eventually we did the equivalent of a pull request into main, triggered the workflow. The workflow logged in, is now doing a build, it's pushing the container image. And now it's doing the cleanup. Yeah, and so here you see it actually, the image is signed. And then we did the push. It cleans up, and then we're done. So that's pretty much our demo for tonight. So how you can, it kind of shows that it is actually reasonably easy to implement if you're already using pipelines and you're building containerized workloads. It shows you that with not too much effort, you actually can start to implement a secure software supply chain for your containerized apps and services. So I hope that you guys got something out of the demo. If there's any other questions, happy to take them right now.
Can I do the same deal in ADO, just like I can?
Yes, you can do this with ADO. I chose to use the GitHub Actions because not everyone's got ADO, but yes, you can do this in ADO. There actually is in the Azure documentation, in the Container Secure Supply Chain docs, there is a quick start for doing this with ADO.
What's the action called? Is it something around the signatures?
Yeah, it's just going to be, it's just going to basically, you're going to put this in your pipeline, right? So you'll probably put it in.
No worries, I can find.
Yeah, I mean, once you're building your application. So at the time you're going to create your container where you want to, basically wherever you're going to do a build and run any tests on the Docker file, that's where you'd put it.
Looks like it's code notation.
Yeah, it's probably just notation, signing.
Notation signing, got it.
Yeah.
So once you've signed the image and put it in the registry, does it look any different in the registry?
No.
How do you know it's signed?
You know it's signed. Well, one, you can verify it with notation. Because it does have the hash. So if we look at the image in the repo. Oh, this. Yeah, there we go. Let's see. Settings. For my repos.
Services.
Settings.
Oh, there, yeah, there it is. Yeah, there. So it's got the digest on it.
Ah,
So, yeah, so, and that, that signing, the digest, you can use notation to verify your image.
so that's my next question. So it's in the repo. Well, good, it's signed. How do I, when I pull it from my Azure service of choice, validate that image?
Yeah, to verify the image, you could use notation to verify the image, to verify the signature. And once you've done that, then you say, oh, yeah, now I can go and do what I need to do with it. Anything else?
Signature as in, this is just the encryption, you mean to say, right?
Signs it.
Yeah, this is the image. Yeah, basically the image is signed.
Signed as in like using that certificate?
Yes, it uses that certificate. It uses that certificate
Sign it?
to sign the image. Yeah.
Oh, okay, gotcha.
But now once you've got the signed image, when you pull the image, you can use
Already has a certificate.
you can use
Private key.
notation to basically say, oh, let me verify this, let me verify the signature on this certificate. So if you're using that since it's a signed image, you use notation with the same certificate that it was signed with, you should be able to get the code and you should be able to get to generate the digest and be able to verify the image. And then that way, combined with the software bill of materials, you have ooh. Yeah, but so combined with a software bill of materials and a signed image, you have confidence in what you expect to be in that image is actually in that image.
In that image.
Yeah, exactly.
It's just a hack proof basically.
Because that's the thing, right? If you just go to grab anything on a Docker Hub or your best friend's Azure or AWS container registry, you don't know what's in there, right? I mean, and like we were talking about, some software hacks, right? The XZutils, which was in the Linux distros, and SolarWinds. Those exploits weren't in the software applications themselves. They were in the components.
Mhm.
They were in libraries that those things use. And that's the kind of problem that we're trying to address with a container secure supply chain, with the scope turned down to, containerized applications of Kubernetes, whatever, Kubernetes on, ACA, Rancher, apps that are orchestrated by Rancher, self-managed Kubernetes and whatnot.
Is the signing process that you demoed, it's compatible with other container registries, right? Like other vendors?
Oh, yeah. Because Notary is an open source project. Or if the Notary Project is open source. Notation is an open source tool via the Notary Project.
You done?
Yeah. So yeah. Before we go, I just want to give a shout out to some of my teammates, Toddy Molednov, who and Rita Zhang from the AKS upstream team. That's the part of the AKS org that actually contributes to open source projects like the Notary Project. And they were very helpful in help me with the materials to put together the talk. So I just wanted to give them a shout out in public. All right, and with that, we are done.
Right. Right. Who learned something? Okay, good. Wasn't a wasted evening then, right? Learn something new. All right. Thanks to everyone for coming out. Thanks again for Russell. Thanks again for Avanade for hosting us. Next year, we have, what are we doing? January. Elastic. Yeah. Elastic are coming in to talk about their Elasticsearch service in Azure on January. Yeah. So it's not the usual time. We're having to do it currently the end of the month because speaker, that's when they can make it. But nonetheless, look for that posting shortly. We'll look out for that, and we'll hope to see you all come out then. In the meantime, have a good season and Happy New Year, everyone.
Right.
Yeah, see you next year.
Thanks
Thanks all. Yeah.